Hi everyone, this is Luke. One of the most interesting capabilities of Accelerate is the ability to create arbitrarily complex patterns, locate them within data, and show or extract the data that satisfy the corresponding conditions. Before illustrating this, we need an introductory remark. Characteristics of data in a cell can be specified symbolically. If the cell is numerical, formatted or not, we can use size symbols, greater than, equal to, and so on, in combinations with and or, to specify desired content. If the cells are textual, we can use character combinations and standard wildcards, question mark and asterisk, to specify desired content. Table 1, shown below, is a small table of integers. The next line displays the even integers in it, and the odds could be obtained similarly. Table 3, showing hypothetical employee information, contains standard text and formatted numbers. The following lines illustrate the showing of items or cells according to criteria demonstrated in the opening remark. Notice that these actions identify as needed the text cells, or cells that can be interpreted as numerical. The overall type of the table does not matter. Now we will construct and use more complex patterns involving rectangular blocks of cells. The block patterns specify requirements in various locations. When the requirements are met, the entire rectangle is returned. The locations with specifications must be sufficient to determine the desired rectangle. We will show several examples. Here is pattern 1. It specifies two conditions that a 1x3 rectangle must meet to be chosen. We will apply this pattern to the table Data Table 1, shown next. There are three ways of applying this pattern. The blocks can be shown in their current location, they can be extracted to form tabs of a stack, or each location can be noted by returning a 1 in its upper left cell. We illustrate these actions in turn. Here, all the blocks are shown, although some may overlap, but any successive 3 will satisfy the conditions. Still, to avoid any confusion, enter the following action. Now the blocks form tabs of a stack, allowing you to export the results as an Excel workbook, or just view the blocks separately. Finally, block locations are shown as 1s in this last action. We note in passing that a pattern can easily be created by hand using the action Create Table. Pattern 1 could have also been created from a simple alpha list, as shown below. Now we perform a more complex search. For this, we use the dataset Table 1, shown before, and the pattern, shown below. The non-blank entries are sufficient to determine a 3x3 rectangle. The pound sign symbols will be interpreted as equal signs. This is done so as not to conflict with Excel formulas. We now show the results of this search. There are 7 such blocks, but to see them, you must move to the right-hand side and scroll horizontally. To see them individually as tabs of a stack, use the action below. Our final example uses Text Table 2, shown below, having text and numbers. It contains records that could refer to customers who purchased a hypothetical package. It has last names, states of origin, dates of purchase, money paid or owed, and so on. Similar examples could have blocks that represent medical patients and contain much larger and more specific information. This table has 16 records, but could just as easily have 1600. Let's look at pattern 3. It will return a 3x4 block if the upper left entry is a name beginning with capital B, 4 columns to the right is greater than 100, the cell under the name is a state name beginning with capital O, and the cell under that refers to the year 2018. Let's extract these as a stack. Pattern 4 is much more general. Now we want names beginning with capital B or C who owe money. The cells having 2 asterisks are just there to specify block size and are not additional conditions. We do not care about what is in those locations, and we will always use the double asterisk if just needed to show block boundaries. We could just as easily extract those people whose accounts are current. Now extract all these blocks. It is easy to construct patterns of arbitrary complexity and use them to investigate blocks of data from any table. Thank you for watching.